Right, let's have a go at 12 then. We've got y equals e to the x cubed, something cubed. Are we all happy that we can try this being something? Yeah, now u cubed we can differentiate, so that should be the key then. So try u equals e to the x, then y is equal to u cubed. Yeah, agreed. Let's draw a grid. So we get some method marks at the very least, if we get it right. Du dx then. E to the x differentiates to e to the x. Y du. 3 comes down, it's a power, 1 less is 2, so 3u squared. Here's the answer. So then dy dx equals dy du dx, these two times together. So dy du, I'll put it that way round, which is the way round anyways. You get that. And then at the end we can put back in what u was equal to. 3 times u, e to the x, that object squared, times e to the x. Right, now so that's e to the x cubed, isn't it? So that would be 3 e to the x cubed. Back to where we were, with a 3 there, 3 lots of. Yeah, so that's the answer then. Now, this raises some interesting questions because I just did that blindly without thinking about the problem, because really, you can simplify the answer here, but you could also simplify the question. So why don't we simplify the question and do the same process just for interest, completeness, sake of completeness. You see, e to the x cubed, I'll put the little power rule here that we need. Remember, power, x to the a to the power b, power u times, so a times b, yeah? Anything to the power like that. U, power u times, okay? Yeah? So we've got e to a power, yeah? So you times these two objects together, so that'll be e to the 3x. So rather than do that, what we could have done is we could have written y equals e to the 3x just by using properties of indices. Then what we would have tried, let's see if this works, try u equal the something. E to the something, agreed? 3x, yeah, we're happy with that. So what have we got then? Well, we'd have, what would we have? Y would equal e to the something. Du dx, oops, would equal 3. Dy du would equal e to the u differentiates to e to the u. So what would we have then? Here's the answer. These two. So dy dx then is equal to dy du dx. 3, this times this, I'll just put 3 times e to the u, which would equal 3 e to the u, which was 3x. And that's the same. See it? We used that property there, that was equal to 3x, e to the 3x, so this was the same as that. Then we used this substitution and got the answer here. But if you look back here, if we had tidied this up using the properties of indices, we'd have ended up with 3x there, power u times 3x, e to the 3x, same. So this is the same as that. Unsurprisingly, doesn't matter which way route we used, we would obviously get the same derivative, wouldn't we? So, you know, the preferred method is to always tidy something up before you differentiate it, really. Like we've done many times before. You tidy it up in the best way possible, then you differentiate, and then you tidy up the answer. That's usually the general template to use. Alright then, but carrying on blindly like this, it would be fine. This is correct. Okay, it needs simplifying, but it's still correct. No problem really. Okay then, let's go on to the next one then. Good.